Hi everyone. In the previous video, I gave you an idea of what limit is, and I also told you that how you can prove whether a limit exists for a given function or not. In this video, I am going to tell you algebra of limits and some standard results as well. So let's see algebra of limits. Algebra of limits says if you have things like this, limit x tends to, let's suppose it is c, and if you have some constant value over here, then your answer would be just a constant, because here no variable in x is present. That's why your answer will be just a constant. If you have certain value, or I can say the expression, the function is in the form of, let's suppose it is x square plus 1, or simply I can write it as, let's suppose it is x raised to power n, then the answer would be c square plus 1 for this, or I can simply write it as c raised to power n. If your limit is given to you x tends to c, and some constant value is multiplied with the function, then this constant value can be taken out and you can simply write it as x tends to c, x, which can be written as limit. When you will put x tends to c, that means your answer would be lambda c. If you have limit x tends to c, and if two functions are in addition, then you can distribute this limit to this function and this function as well. So you can write it as limit x tends to c fx plus limit x tends to c gx. So limit x tends to c stands for both. If it is given in minus, then obviously it will be minus, and the limit will stand for both. If you have limit x tends to c, and if two functions are in multiplication, then again you can write this limit for both the functions. That means I can write in this way. Similarly, if you have functions in division, then again you can write this limit for both the functions. Fx whole upon limit x tends to c, so gx. Now, if you have just your function like this, limit x tends to c 1 upon fx, then also you can write it as 1 upon limit x tends to c fx. So this is algebra of limits. This is how you can put this limit if two or more functions are given to you in the question. Have a look. Now, before moving on to the standard results of limits, let us define indeterminate forms. Indeterminate forms are those forms which are not defined, which cannot be defined, and the forms are 0 by 0, infinity by infinity, minus infinity, positive infinity, or 1 by 0. So these kind of things are indeterminate forms. That means the value cannot be calculated. If you get your answer or denominator in 0, infinity form, then you need to change your question into some other form. Now, on putting the limit, if you get any of these form, then you will be converting or transforming your given question in some other form. Now, limits are categorized into two types of problems. One is your algebraic limits, other is your non-algebraic limits. Algebraic limits means if you get your question in variable and constant form. Let's suppose if you are getting your function fx equal to x square plus 1, or if you are getting it as, let's suppose, 2x plus 3x square upon 4x plus y, 4x square. So this is your function in algebraic form. So if your function is in your algebraic form, then you can apply the formulae which I will be telling you now. For non-algebraic limits, you will have it as your trigonometric functions. You can have exponential functions, and you can also have logarithmic functions here. Logarithmic functions. Alright. Now, if your question is, now first of all we'll learn, if your function is given in algebraic form, then what methods you are going to apply and how you are going to solve it. So if we are given with algebraic form, functions are in algebraic form, then we can apply these methods. First of all, you can apply method of direct substitution. That means you can directly substitute the value of limit in the given function. For example, if it is given function limit x tends to 2, and if it is x, say it is x plus 2, then you can directly substitute the value. So substituting the value, you will be getting it as 4, and you are not getting any of the indeterminate form here. So this is your direct substitution method, in which you just put x equal to this limit. Now, second method is method of factorization. Method of factorization. For example, if you have function like x square minus 4 is equal to limit x tends to 2, and if you have question like this, then if I apply first method, that is direct substitution method, then here in the denominator I will get it as 2 minus 2, that is 0, which is your indeterminate form. So I have to change my question into some other form. So I will be factorizing it now. So I can write it as limit x tends to 2, x plus 2 and x minus 2. Here x minus 2 and x minus 2 gone. So I'll be just left with limit x tends to 2, x plus 2. Now I can substitute the value of x as 2. So I'll be getting my answer as 4. Third method here, I have method of rationalization. Method of rationalization. This method is used when you are given with root functions. Let's suppose if it is given fx equal to under root x plus 2 whole upon under root x minus 2, and let's suppose here it is given to you limit x tends to 2. So again, if you are applying direct substitution method here, then this will give me indeterminate form. So I have to convert this question into some other form. That means I will be rationalizing it, since my function is in root form, so I will be rationalizing it. Now the fourth method is using the formula, and the formula is limit if your x tends to a, and if you have function in this form, that means x raised to power n minus any constant raised to power n, and here you have this variable and this constant, then you can directly write it as n into a raised to power n minus 1. But before using this formula, you make sure that whatever constant term you are getting here should be the limit. That means x should be tending to the constant value which is given in the function. Alright, so these are the methods which you can use when the function is your algebraic functions. Let's see over here, when the function is non-algebraic function, Then if it is trigonometric function, then you have three formulae here. Limit x tends to 0, sin x by x can be written as 1. Secondly, limit x tends to 0, tan x by x. If you get your function in this form, then you can write it as 1. Thirdly, remember this and learn this very carefully, because cos x by sx will not be equal to 1, but if you are given with limit x tends to 0, 1 minus cos x upon x, then this value will be 0. So these are the three important trigonometric function formulae. When the things are given in exponential form, then the formula which you have to remember is limit x tends to 0, e raised to power x minus 1 by x is equal to 1. Whenever you are given with some exponential function, then you need to convert the given question into this form. Alright, limit x tends to 0, e raised to power x minus 1 by x equal to 1. Always remember, these are the standard formulae when your x is tending towards 0. Alright, when it is logarithmic function, then you will be writing it as limit x tends to 0, log of 1 plus x whole upon x, and which is equal to again 1. Alright. So these are the various methods and these are some standard results which you can use in the questions to solve the problem on limits. Try to remember these formulae and we'll do some of the questions in the next video.